Many shared interactive surfaces for multi-users like tabletops or interactive walls are not able to distinguish different co-located users interacting on a shared input surface. Typically, without user distinction capabilities, conflicting concurrent user inputs might produce unwanted behaviors, making it impossible for multiple users to interact simultaneously. We propose two new concepts called task-based focus and AdHoc-Focus-Territory to support multi-user parallel interactions on shared interactive surfaces without the need of user identification capabilities. Consider, for example, multiple users trying to edit single graph nodes simultaneously. Typically, you will prefer to activate a context menu of the node you want to edit, and then choose the edit operation that should be applied on the node. And for changing some texts of the node, you will expect double tapping on the text inside the node to activate a text input widget. Unfortunately, in traditional GUI toolkits, the behavior of the context menu and the text input widget rely on the single focus model, which determines that only one widget in the whole application can be selected at a time to exclusively receive user inputs. With multiple users interacting on a shared interactive surface, a context menu or a text input control will immediately be deactivated as soon as another user's touch occurs. Using no focus at all is not a good solution, because in some cases it requires users to explicitly deactivate or close the UI elements. With a task-based focus, we can avoid accidental conflicts caused by the single focus model. The idea behind this concept is that we can assume that only one user will simultaneously interact with a group of UI elements related to an individual task, like deleting a graph node or filling out a search form. We call this group of UI elements focus area. The most important aspect here is that all elements inside a focus area will not be affected by user inputs occurring outside this focus area. This means that user inputs outside the focus area A will not close a context menu or deactivate the text inputs of the focus area A. This is actually what we can use to prevent users to accidentally deactivate context menus or text input controls of other users. However, all elements inside a focus area share the same focus, such that a selected element remains in focus until another element within the same focus area gets selected and gains the focus. This means that from the user perspective, nothing has changed in the interaction with UI elements within a focus area, since all UI elements will still behave according to the single focus model. For example, to close the context menu of a single node, users must either select an option of the context menu or touch another UI element inside the focus area. Since each graph node is defined as a focus area, the same soft keyboard instance is also shared between all text input controls inside the focus area. The grouping of UI elements to a focus area must be done at design time by the application programmer. However, in some situations, a focus area can only be defined by the users themselves at runtime. Users can also create a transient task-based focus area at design time by drawing a selection box to select multiple objects. Because any user input outside a selection box has no influence on the UI elements inside the selection box, the selection box and its context menu cannot be accidentally closed by other users. And users can manipulate multiple nodes at once in parallel. We call this approach AdHoc-Focus-Territory because it helps the ad hoc generation of transient focus areas.